Good morning. It's me. I'm going to be doing your square heart. In order for this to work, you've got to do the steps that I tell you, including pausing it and going over things with your partner. But the square heart is something that my students have come back and asked for up into college. It's like my most asked for thing. So to start, you've got your piece of paper and you are going to draw a square. Your heart is not square, but I'm flattening it out so you can see what's happening in 2D. And you're going to draw squares in the square. So you're starting with that, and then you're going to need a red and a blue because your blood comes in two colors. Sometimes it's really bright red, and then sometimes it's blue, and it's not actually blue. It just looks blue through your skin. It's like a really dark raspberry color. So if I were teaching this to you in class, I would start to ask you if you know the name of this blood and you know the name of this blood. Not the blood, but the tubes that carry it. So I'm just going to tell you. This blue blood is always in veins, almost always. And it's carrying blood that has no oxygen in it. So it's deoxygenated. Instead, it's carrying CO2. I call it trashy blood. And then we've got the bright red blood. So these are oxygenated. This is carrying what your cells want. This is carrying your cell trash. So I also look at this as a ride at Hotel Cell, where this would be probably my most fun ride. It'd be a roller coaster. Anyway, there's 4 chambers. The top 2 are atria. Actually, I'm going to change this to atrium. One of them is an atrium. Both of them, if you're referring to both, it's your atria, your top 2, plural. The bottom 2 are called ventricles. Okay, my ride. You are going to be looking at this heart as if it is your patient and they are laying on the table. So if this is your patient and you've got their heart open in front of you and you're looking down at it, this side of the patient, what side would it be? Because I know that this is the left side of the heart when I'm looking at it, but for your patient who's laying on the table, that is their right side of their heart. So this is always the right atrium and the right ventricle. And this is always the left atrium and the left ventricle. And in medicine, it's always labeled that way. Same thing with the lungs. If whatever you're talking about, it's as if you're looking down onto your patient's body. Okay, so to start, you're going to get on the ride right here. You are in a blood vessel that is draining from the brain. It's pretty big. You can stick your pinky in it. And you are going to get on the ride and immediately drop into this building on my ride at Hotel Cell. And it's going to be kind of dark in here and blue. And you can hear the sound of a heart. So you shoot down into here. You're coming from the brain. And you enter the right atrium. Some people are going to get on the ride on the other side. And they are coming up from the legs, the liver, the stomach. So all blood starts by entering the right atrium of the heart, and this is blue deoxygenated blood. These 2 blood vessels have a name. This is the superior, and what's the opposite of superior? Inferior. Vena cava. Superior vena cava, draining deoxygenated trash blood from your brain and arms. Inferior vena cava is draining blood up to this part. So you either shoot straight up here or you shoot down into here. And I'll tell you in a minute, but on my ride, you're going to have your head strapped back to this seat because sometimes you're going to be going up and backward. And so I think I'd probably get sued from neck injuries if I don't have you strapped back into the seat. Okay. So here you are. You're going to be...
Could you try again?
Here you are. You're going to be in my the right atrium. And this will be a quiet room. It's blue. And you're just going to sit there for a second. This little wall is going to be see-through. That's not true in the heart. But for my ride, you're going to see into this one. But you don't get to know what's over here yet. And then all of a sudden, there's going to be this click. And you are going to free fall down into this right ventricle. through a trap door that you never knew was there. This is going to be serious free fall. Like, people are going to scream. You didn't know it was coming. It's going to be like, I don't know what, a big one. Those big scary ones. All right, trapdoor. Of course, that trapdoor has a name. We'll name it later. So now we're here in the right ventricle. This right atrium is just like a holding chamber. The right ventricle is the thing that's muscly and does the pushing. So it is going to pump our blood somewhere. And then the question is where does our blood even need to go? Well, it's blue and full of trash, which is not helpful. We need to get rid of our CO2. My question to you, if I was teaching you in person, would be, where would you get rid of your CO2 in your body? Like, what part? I'd pause it. Tell your partner. You have to exhale your CO2. So because of that, the right side of the heart has to pump this trashy blood, which is the only thing that's ever over here, is blue trashy blood. So it's going to pump it to the lungs. And I'm only going to draw one lung. You have two. You have one on the other side, but this picture gets nuts if I do that. So I'm going to do this to the lung. This is your amazing lung. So we're going to pump this blue trashy blood to the lung. And instead of going out the bottom, which totally would make sense, your heart's like, nah, I'm going to make it a little bit more complicated. We're going to go straight up, but not back into here. We go behind this. There's like this tube that goes backward and straight up. This is going to be super fun. And this is one of the reasons your neck has to be strapped. Your head has to be strapped back to the seat. Once you free fall into here, one person's crying. All of a sudden you shoot up and backward behind this. And I can't draw it, but you are going behind that to some crazy, like really high loop thing where you're going to shoot up out of this building super high. If you've been to Knott's Berry Farm, they have this like paperclip ride where you shoot straight up at 1,000,000 miles an hour. It's so scary. Here you go. Woohoo! You're not going to quite make it either. That's the best part. You're going to get up here and you're like, oh my gosh, and then you're going to not make it. You're going to stop and start to fall backward. And at that same time, you're going to know that someone else is down here. They're about to shoot up. So it's very scary. You're not sure if the ride broke. People are throwing up. Everyone's crying. And as you start to fall backward, you hit yet another secret door that you didn't know was there. And you don't fall backward. And then all of a sudden you get pushed out again. So that's the heart beating. Every time the heart pushes, you're like, didn't quite make it. And then it beats again. And then that time you make it. So the second heartbeat, you're like, woo, to the lungs, to the lungs. People are excited to go to the lungs because we're going to get rid of our trash there. So here we go. Out here, we go to the lungs where we drop off our CO2. We don't want trash. You are currently exhaling that CO2 right now. Also in the lung, as soon as you drop that off, your body's like, oh, look, some oxygen. And it'll pick oxygen up. The moment you do that, your blood turns like a different color. It looks much redder. Okay, so here we are, and our blood is oxygenated. Now I have all the O2 to give to my cells. For example, a knee cell, a cell in your, here it is. There's your knee cell. It wants this oxygen. So you would think that the body would just send it straight here. But we want our ride to be absolutely the best that it could possibly be. So we're going to need to make sure we keep going fast. So for example, like on the Pirates of the Caribbean, in the very beginning of the ride, you get to go down like these little fast parts on the ride. And then the second half of the ride is really slow. Like you just, sometimes you're so slow that you actually float backward. I don't know if you've ever been stuck on that ride, but I've been stuck on it for like a long time because you're not going forward. We don't want that for our heart because our cells aren't going to get enough oxygen fast enough. If you were a fish, any fish, including sharks, you would go straight to the cell. But our heart has evolved since then to have a whole second side to give us a second shove. So here we come back to the heart for an amazing second shove. This time when you get in here, you know what's going to happen. You enter the left atrium, you trickle down, and into the left ventricle, but you know that there's a trap door. So you'll be sitting here, you'll be able to see these people, and you'll be laughing, but you'll be slightly scared because you know that you're going to fall down into here, and you'll hear a click, and you'll fall straight down into here. This is a holding chamber. This is a place where a lot of serious pumping happens. This side of the heart has to pump to somewhere different. So this side only pumps to the lungs. This side has to pump somewhere else. Where are we pumping to on this side? And by the way, the right side of the heart, the left side of the heart only has oxygenated blood. That's right. We got to pump to the entire body. If you are like, an elephant or something, you've got to get all the way back to your back legs, down to the toes. We're going to have to go pretty far. So this side of the heart has to pump harder because it's further away. It's got to pump further. The whole left side of your heart is thicker and more muscly because of that. It has farther to go. A blue whale is a mammal, not a fish. It has to pump like blood way back to the back of the tail. So its heart is huge. You could crawl through the heart of a blue whale. You could fit in this tube right here. Be like at the, maybe I'll make a little playground for kids that's like a blue whale heart and you can crawl through the tubes. Okay, anyway, so now we're here and we're going to get shot to the body, and instead of going straight out the bottom, why would we do that when I could have you go straight up and backward to the body? This is going to be even worse, by the way. It's going to probably go above that one. It's going to be the fastest thing in the whole world. This is your biggest artery, and you're heading out to the body through this gigantic blood vessel. You would never want to pop that one, and you're not going to make it, and you're going to fall backward. And there's going to be a nice little trap door for you so that you don't fall back into this building and everybody dies. That'd be bad. So, to the body. In fact, we'll write that. To the body. To the body. If you've ever been on Indiana Jones at Disneyland, there's like 3 different routes you can take. This is going to be the same thing here. This blood vessel branches. Like there's a branch that goes up down your right arm. There's a branch that goes up your neck. There's a branch that goes down your left arm. There's branches everywhere. This blood vessel right here is called your aorta. And we're going to the body. Please note I purposefully did not name this one yet, and I have not named this one yet. To the body. And you go straight backward. And this gigantic blood vessel runs right behind your heart a little to the left. So this is going to shoot up and back behind the heart. And if you think about your body, then it's going to go up, backward. And if that's your patient, it's actually a little to the left. So it will run right to the left of your vertebrae all the way down your back. It's a big blood vessel. Wouldn't want to get stabbed in that blood vessel. Don't let anyone stab you in the back to the left between the ribs. Okay, so we're going to the body and we're going to drop this oxygen off, and we go and we branch off. And every time something branches off, this is the worst drawing ever, these are called arteries. They're pretty big. You can feel the one in your neck right here. It's when you can feel a pulse in something, those are only these red arteries. They're very deep to protect them, because if you cut one, blood will spray out with your heartbeat. So you'd never want to cut an artery. You'll know if you cut an artery because you'll see your blood shoot out a couple inches every time your heart beats, which is never going to happen to you. And you don't need to worry about it. Everything you ever cut is these little blue blood vessels. So these, you can feel your pulse in your wrist. There's one. It's way deep in there. There's one right here. There's one right here, your brachial artery. Everything to do with your arm is brachial. That's why if you put your arm over like a fence and just kind of hang on it, your whole arm goes numb because you've pinched this artery. You can feel one right here. I can feel it's on the out, like toward the medial side of my arm. If my palm is up, it's on this side. It runs, there's one that runs down the back of your leg behind your knee. Anyway, you can feel your pulse. They take pulse of babies right here, right where your leg meets your rest of your trunk of your body. You can get a pulse there, which is why when you sit crisscross, your legs go numb. You're pinking a giant artery. Anyway, so we're going to do arteries, and then they get smaller, little tiny ones. These little ones are called arteries.